In the previous video lecture, we discussed about the resistors in parallel. Now in this video lecture, we will be discussing another example which is related to the resistors in parallel, in which 4 resistors are connected in parallel in this box type shape. And the resistance value of our 2 resistors is 24 ohm, the resistance value of our 3 resistor is 24 ohm, and the resistor value of our 4 resistors is 120 ohms. And the total resistance, or this equivalent resistance of these resistors, is given to us, which is 10 ohms. And we are asked to find out the resistance value of this first resistor. If you analyze this network briefly, then you would see that these 4 resistors are in parallel connection because R1, R2, R3, R4 is connected to point A and point B. These 4 resistors are sharing the same 2 points, so these 4 resistors are said to be in parallel. In this question, we are just asked to find out the resistance value of this first resistor. Now, as we know that the equivalent resistance of this parallel connection or this parallel network is equals to 1 divided by RT is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus 1 divided by R4. So 1 over RT is already we have, which is 10 ohms, is equals to 1 divided by R1 plus 1 divided by R2. R2 is 24 ohms plus R3 is already 24 ohms plus 1 over R4 is 120 ohms. Now after calculating this, we get 1 divided by 10 is equals to 1 divided by R1 plus 11 divided by 120. Now to find out R1 from this equation, so let's move this 11 divided by 120 into this side of equation. So we get 1 divided by 10 minus 11 divided by 120 is equals to 1 divided by R1. Now after calculating this, we get 1 divided by 20. 120 is equals to 1 divided by R1. So the resulting resistance value of R1 resistance is 120 ohms. Now let's take another example which is related to resistors in parallel to understand this in a more brief way, in which we have a DC voltage source which is connected in parallel with 3 resistors R1, R2 and R3, and a DC voltage source is having a potential difference of 48 volts. R1 is 12 kilo ohms, R2 is 18 kilo ohm, while R3 is 3 kilo ohms. These 3 resistors are said to be in parallel because these 3 resistors are sharing the same 2 points. One end of these 3 resistors and this DC voltage source is connected to this point, and the other end is connected to the ground. Now by redrawing this network, we get this 48 volt source is connected in parallel with R1, R2 and R3, and the other point of these 4 components is connected to the ground. This point shows the ground of this network. The positive side of this DC voltage source is connected to this point, which in this simple circuit is this represent this point, and the other side of this DC voltage source is connected to the ground. And as of R1, R2 and R3, let's say this voltage source is E, this resistance is R1, R2, R3. So from this we can easily analyze that these 3 resistors are in parallel with this DC voltage source. So in this question, we are asked to find out the total current from this DC voltage source. So first of all, we need to find out the equivalent resistance of this network. So the equivalent resistance is, let's say, 1 divided by RT is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Now 1 over 1 divided by RT is equals to 1 divided by R1. R1 in this case is 12 kilo ohms plus 1 divided by R2, which is 18 kilo ohms, plus 1 divided by R3, which is 3 kilo ohms. So the equivalent resistance of this parallel network is 1 divided by RT is equals to 17 divided by per ohms. So now the equivalent resistance from this equation, RT is equals to 36,000 divided by 17 ohms. So after calculating this we get, so RT is equals to 2.118 kilo ohms. Now to find out the current from this source, we can use the Ohm's law, which states that E is equals to Is into RT. So Is from this equation is equals to E divided by RT. So the resulting current through this source is equals to E is 48 volt divided by RT is 2.118 kilo ohms. So the resulting current is equals to 22.67 milliampere. So the resulting current from this DC voltage source is 22.67 milliampere. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.